Hello, Cambridge families. We really appreciate you looking in and listening in. If you are viewing and listening to this presentation, that means that you have an interest in studying non-AP or possibly AP Calculus at Cambridge High School. My name is Brian Wynn. I'm a math teacher here at Cambridge High School, and I'm also the Mathematics Department Chair at Cambridge High School.
Hi, my name is Emily O'Dowd, and I am a math teacher here at Cambridge. And our goal today is to provide a quick overview of 3 different calculus classes and help you make an informed decision about your future math class. So what you're looking at is all the topics between Calculus AB and BC Calculus. The AB topics are also going to be taught in the non-AP Calculus. The difference between the non-AP and the AB Calculus is going to be the depth that we go and the rigor of the course, because we're preparing for the AP exam. And the non-AP is more of a general study of the calculus.
And in AP Calculus BC, generally speaking, what Ms. O'Dowd said still rings true. The chief difference between AB and BC happens to be just the amount of content. As Ms. O'Dowd was kind of illuminating, if you look at the left-hand side of the PowerPoint slide, you can kind of see some of the specific topics. With AP Calculus BC, as you can imagine, it's the same topics that are taught in AB plus several more topics. So in BC, we generally finish all of what is AP Calculus AB by December. And when we come back in January, not only do we come back to a new semester, but we also come back to new topics that are not included in the AB course. So when we start thinking about those topics generally are related to vectors, parametric curves, polar coordinates, and polar equations, and we do a huge study for about 6 weeks on infinite series and deciding whether or not a particular infinite series either converges to a value or it diverges. So, but in both of these courses, whether it's AP Calculus AB or BC, we have to strike a balance between both the concept and the procedure. So, as Ms. O'Dowd was saying, in non-AP Calculus, you get a nice survey of calculus that could theoretically prepare a student, for further study in calculus. But in AP Calculus, whether it's AB or BC, we really have to get at the heart of the conceptual underpinnings of calculus, because that is how the AP exam is really structured. There are just questions that are, can you find this derivative? Can you calculate this definite integral? But there are also a lot of why questions. Why do we set the derivative equal to 0? What does this mean value theorem really mean? How do we know that we can apply it? So there's a huge conceptual piece that we have to accommodate in AP Calculus.
So these are the numbers that we generally see that show success in these 2 courses. So if you are a student in accelerated pre-calculus currently and you have an 80 or above, you would probably be very successful in AP Calculus AB. Or if you're in the pre-calculus honors course, we recommend a grade of 93 or greater. And these aren't the hard cutoffs, these are just the numbers that we see that generally show success in AP Calculus AB.
And in AP Calculus BC, we roughly look for, generally speaking, we look for from pre-calculus, and for this particular school year it's accelerated pre-calculus, because there are topics in accelerated pre-calculus that would not necessarily be included in pre-calculus honors that a student would need to learn and have a pretty decent understanding of to come into BC and to be successful. So we generally start by looking at the first semester of pre-calculus with a 92 unweighted average, and probably also without having to do recovery. But in addition to that, we also go back and look at what the average looks like from the previous year's study, because as you can imagine, calculus is very heavily reliant upon good algebraic skills. So we also go back and look at accelerated geometry B / algebra 2 honors. If a student had consistently had A's in both semesters, we generally say, yes, that student has a very good foundation in algebra, and couple that along with the 92 first semester average in pre-calculus, we generally will say that student is probably going to be successful in BC. So in terms of indicators of success, notice that a huge part of a student coming into AP Calculus and being successful is they have to come with a strong work ethic. So having good grades is certainly a piece of it, but we want students in there who can really come and almost revel in the content. You have to have a sincere interest, otherwise the class tends to not be terribly enjoyable. And we also want the student to be a good thinker as well as a good contributor. So when we have, believe it or not, we do have class discussions and we do pose a lot of questions. Ms. O'Dowd and I are both very keen on playing dumb every day, because we believe that our job is to pose good questions that will prompt students to think, and we also like students to contribute ideas during these discussions so that within that moment we can appraise the ideas of the students. And it's not uncommon for us to, instead of us correcting the student who answered, who may not have answered perfectly correctly, we generally will call another student to say, can you help so-and-so refine his or her thoughts? So we try to get as many people involved as we possibly can. Our third bullet point really would apply to any math class, but in particular our class, completing homework is vital to success, because clearly people perform as they practice. So if a student doesn't really do a consistent amount of homework and tries to be successful on tests, you know, we have pretty much seen people not do well with that. So we definitely want to just put that out there, that students need to be really consistent about doing homework. And we also know that we're teaching a college level math class to high school students. So both Ms. O'Dowd and I are always willing to give students extra help in the morning, during class time, after school, and other times by appointment. So do not, under any circumstance, wait until, you know, the material, the difficulty has compounded. Make sure that you're not shy about asking for help. You know, there is a maturity factor, both a social maturity and a mathematical maturity, which kind of goes back to what we were saying on a previous slide. We've got to make sure that we have good, solid skills from pre-calculus and from algebra, because AP Calculus, or just calculus in general, is one of those places where all those skills get marshaled, and we have to make sure that students are ready to use those skills. And also good attendance. We want to make sure that, you know, every day one concept builds upon the previous. So we want to make sure that students are here as consistently as they possibly can be.
So these are all the different types of things you might see for assessment in AP Calculus. So our first is our major assessment, which is our tests. So this tends to cover many sections that go together. It can be a blend of open-ended and multiple choice questions. And it's not going to require just a procedure. You're not just going to be finding the derivative of a function. You're going to have to find that derivative, interpret what it means. You might have to do something else with that answer that you got. And our tests are currently worth 55% of the total grade. The quizzes or the minor assessment might cover 1, 2, or 3 topics, so these are going to be smaller, and there might be 1, 2, or 3 quizzes before a major assessment. And these are currently 35% of the grade. The daily homework is the practice, and that's 10% of the grade, and that's probably assigned pretty much every night of the week unless it's an assessment day. Also during class, they're going to be exposed to a lot of AP practice questions. So as we've built up enough knowledge, we're going to look at past questions and give students opportunities to work individually, but also in pairs or in groups, so they can have discussions about all the different topics that this one question might be asking them about. And then we do like to have the opportunity to give an AP practice exam as we get closer to the actual AP exam in May. So a full-length practice exam to give them the feel of what the real exam is like.
And you'll notice on this slide, it really discusses and highlights the format that we see on the AP exam. You will notice that the very first section is 30 multiple choice questions, and those are done without calculator. That really is where we test a student's mechanics. Can you find this derivative? Can you calculate the average value of this function? So that really is kind of the welcome to the exam part of the exam. The next part of the exam you will notice is the graphing calculator multiple choice questions, and you'll notice that they have almost the same number of minutes, roughly 15 minutes shorter to answer half the questions. Well, the reason that it's structured that way is because that happens to be where students are really expected to demonstrate more of their conceptual understanding. It's not to say that the graphing calculator is going to be used on every single question, but students will notice that this is going to be a place where they really start getting deeper in the conceptual underpinnings of what we talked about. So once they take the second part of the multiple choice section of the exam, that's pretty much it for multiple choice. The next two sections, even though it looks like it's two sections, it's really one free response section that's split into two parts. It used to be that we would do 3 no calculator questions and 3 calculator questions. Now the way it works is the first 2 questions of free response, those first 2 questions are to be done with calculator, and the last 4 questions are to be done without calculator. So those questions roughly are equivalent to 9 points apiece. And just like they've been used to in other math classes, there is what we would consider to be multiple choice. So students don't necessarily lose points for doing the wrong thing, but they gain points of those, or fractions of those 9 points for doing appropriate things. So for example, even if a student cannot do, suppose the worst happened and a student could not do any part of one of the free response questions, sometimes just writing down the correct units will get the student one of those 9 points. So as you can imagine, just being able to attend to details sometimes is a student's best friend on some of these particular questions. So that pretty much is how that exam is structured. So I will also add to that as you can imagine, by the times, if there are 30 minutes to do 2 questions and then 60 minutes to do 4 questions, it would be reasonable for each student to expect roughly 15 minutes to be spent on each question. So generally there's a stem, and then there are 3 or 4 parts that come off of that stem that students are responding to.
Thank you so much for watching our presentation. If you have any questions, please feel free to reach out to either of us, and our email addresses are provided.
Yes, thank you, and we hope this helps you make some great decisions about mathematics in the future.